Hey guys, how you doing? So welcome back to another video. As you can see, today's setup is a bit different and we have actually changed the setup so that it's easier for everyone to understand the problems and you can expect much more better understanding now from in our channel, the problems, all those things. Now, today we are discussing this problem called diameter of a binary tree and this was asked at Amazon, and this is a very important problem because this is a lot of understanding going beneath this. So without further delay, let us jump into the problem. So we know what's a binary tree, right? So I'll just draw a binary tree, and binary tree is a tree which has two nodes, right? The left child and the right child. So I have drawn a simple binary tree, as you can see, and diameter is basically the farthest distance between two nodes in the binary tree. So what is the farthest distance in this tree? That is, we can see that this one is the farthest distance, right? These two nodes have the farthest distance. Also, since this tree is symmetric, actually these nodes also have the farthest distance. So basically what matters to us, okay, so this is not going, okay, yeah. So what matters to us is the distance that we are traversing from one node to another node. The maximum distance between two nodes is the diameter of that binary tree. So in this case, you can see that this tree and this tree forms the diameter with this path, right? Because and the diameter would be 4. Now the common thought for you might be that let us always calculate the left height and the right height, the height of the left subtree, basically this subtree, and the height of the right subtree. So the left subtree height plus right subtree height plus 2 we can do, right? Obviously, because the height of this tree is 1 and the height of this tree is 1, and this 2 will always be there. So 1 plus 1 plus 2, the 4 will be the answer for us, right? But that is not the case. 4 will not be the answer all the time. Basically, this approach would not lead to a solution all the time. Let us see why. Let us draw another simple binary tree. And we have seen that the diameter of this binary tree is what? 4. Now, let us complicate this a bit. What would be the diameter now? 6, right? This 3 and this 3 here. Let us complicate this a bit further. So you might be thinking that I'll calculate the height of this subtree, which would be 2. I'll calculate the height of this subtree, which would be 2. And 2 plus 2 plus 2 would give me 6. Why 2 more? This 2 is because this one and this one, these two edges. There will always be a edge connected to the left subtree and always be an edge connected to the right subtree. That's an assumption. That will not always be the case, right? But that's what we have to tackle. Now, let us complicate this tree a bit more. Now what we have is this path, right? Let us complicate this tree a bit more and make it something like this. Oops. Yeah. So what is the new diameter of the tree? It was 6 and it would be 7 and 8. So the diameter of the tree following the green path is 8. Let us see, there is another path that can be a diameter also. 1, 2, 3, 4, 5, 6, 7, 8. So this can also be a diameter. Now let us try adding 2 more edges to this path. 1 and 2. Now this new diameter becomes 10, right? Sorry for that. Now this new diameter becomes 10, whereas this old diameter becomes 9 because 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, in this case, this tree is giving me the diameter and not the one that is going to the root. So that is what we have to understand, that the diameter will not always be through the root. It can be a case, for example, we can take a test case, we can take an example where it is something like this. there is no right subtree. There can be something like this. Okay, there can be something like this. So in this case, what would be the answer? This answer would be only this much path. So whatever it is, 1, 2, 3, 4, 5, 6. In this case, answer would be 6. You will not be able to take 1, 2, 3, 4, 5 here. This is smaller, right? You cannot take this path. So the idea that L left height plus right height plus 2 is always going to give me the solution is completely wrong. Instead, what we have to do is we have to give this complete attention to not only the root but to each and every node in the tree. That is, this plus 2 will be gone. We need to find out the L plus H at each node. How do we do that? We use recursion. We use recursion to do that. Now, let's take an example. This is a simple binary tree once again. Okay. What we'll do is we'll iterate for left height plus right height, and we'll try to store that as the diameter. So this is the diameter for a given node. So if you want to center at this node, and if you want to find out the diameter, we need the left height, that the path of the deepest node on the left side and path of the deepest node on the right side, and sum them up. That is the diameter at this node. And we have to iterate and keep on recursing this throughout the entire tree. So what would be the time complexity of our approach? It would be big of n, because we are visiting each and every node only once. So let us see the height at these leaf nodes will always be 0. We know that, right? And the height would be 1 here, height would be 1 here, height would be 2 here, height would be 2 here. So I'm assuming we know how to solve the height problem, the height of binary tree, height of any tree, right? We'll use simple recursion. So that is a sub problem of this problem. So if we know how to solve this problem, solve that problem, we'll be able to solve this problem also. Now we find out what is the height of the left side and what is the height of the right side. So what is the diameter of this one here? So the height of this would here would be 3, because you can see the height is 3, but the diameter here would be 3 plus 1, that is 4, right? Now you go up one step once more. Here the height is 4, 1, 2, 3, 4, and this is 0. So what is the diameter here? 4 plus 1, that is 5. So we are slowly increasing the diameter. So you can get the idea that we'll have to maintain a global max, which will store the diameter, and finally return the diameter. Okay, so we are getting this idea. We're going towards that intuition. Now we'll continue repeating this on this side also. And this is 3 and this is 4. The height of this is 4 and this is 1. So the diameter here would be 5. 1, 2, 3, 4 and 1. This is 5. Similarly, we can get the height here. This is 4 and this is 4. So this would be 4 plus 4 and this is diameter is 10. Note that this is 10 because the diameter came out to be 10 after traversing the entire tree. We are not keeping in mind that the root will be always the center of the diameter. If we do that, our answer will be wrong. Instead, what we need to do is we'll have to keep a global max where we'll store the diameter and iterate the entire tree. So I hope the idea is clear, the concept that we're trying to follow, it's clear, right? Now we'll see the pseudocode, and I'll explain the pseudocode in a very simple manner so that you're able to understand and code it on your own. Now going to the pseudocode. We'll write a simple function called, let's say, get diameter. So what should this get diameter take? It should take the root of the tree whose diameter we want to calculate, right? We are going to define a variable called max diam, let's say, and initialize it to 0. So at the end of the day, at the end of the entire program, we are going to return this variable. This is going to be the global variable within this function, basically local. We cannot say global actually, but we are going to update this one throughout the function. Inside this, we'll create another method called, let's say, global height, or basically you can do it outside also. Just I'm doing it inside for this own purpose, and you can basically pull this outside also, and we just need to update the max diameter. So this function height will take in a node, and if the node is a leaf node, basically if this is null, right, if this is null, in that case we will return 0, as we saw here, right? This null nodes, this is a leaf nodes, have a height of 0, and this is the function height. If it is not null, we have to calculate the left height, which is height node dot left. We have to calculate the right height, which is height node dot right. So essentially, given a tree, we are recursing down. At each point, we're calculating the left height and the right height. So once we have the left height and the right height, what do we need to do? I need to find the maximum of that, because for the depth of the tree, for the height of the tree, I need the maximum one. So here the left side height would be 2 and the right height would be 1. So the height here would be maximum of 2 and 1, that is 2 plus 1, which is 3. So here it would be 3. You got the idea, right? Now, while doing that, so what are we gonna return? We are going to return maximum of left height, sorry, maximum of left height and right height plus 1. This is the height for this node. But we also need to update the max diameter. So what we will do is, before returning, just before returning, we'll update this maximum diameter. So I'll just update this max diameter to the maximum of max diameter, and whatever we get in the left height and the right height. So whatever height we have, that summation of those two heights is the diameter here. And if that is greater than the current maximum diameter, we just need to update it. That's the only statement we are concerned with. That is the main program. That is what is this function is concerned about, right? Now once we have done that, we have returning here, and that basically ends this function, and we are getting the height. Now once we are outside of this, you have to just return max diameter is now populated, it's updated. So you can just return the max diameter, right? Okay, before returning max diameter, this function has to be called. So we have to call this function height and pass the root here. So you call the function height goes here, it keeps on iterating, it updates the max diameter, and once you're outside of this, it will come to this line and it would return max diameter. So this function ends here. So I hope this is clear. So just try to code this out, and I'm sure you would be able to understand how this program is working, and I'm sure this is very clear how this program is working. So thank you so much for watching. I hope this concept got clear with you and you'll be able to solve this problem when asked in the interview. And keep watching the videos and keep liking and sharing and subscribing. They keep on, they keep motivating me to create much more videos. And that's it for today's video. Happy interviewing.